Welcome to the next lesson in this course, building the first module. And this is the first lesson where we are going to write some code. And we are going to start from the events module by creating a few use cases for the event entity or the corresponding events table in the database. Before we begin, I want to make a few remarks for how we're going to approach coding going forward because we have a lot, and I do mean a lot, of code to write. The goal with this lesson is to get started quickly, produce some functional use cases, and validate that our application is working. After that, we're going to refactor this implementation into something more maintainable and continue evolving it over time. One more thing I want to make clear from the start is that it's not going to be feasible for us to write every single line of code that I prepare for this course, which is why I'm going to tell you when I introduce some new code behind the scenes, and you will be able to download the latest version of the source code at that point in time from the link that's going to be under the video. So with that out of the way, let's head over into Visual Studio and start creating our first module. We're going to start from an empty solution for the Evently application. And the very first thing I'm going to add is not going to be any code or project at all. We are going to set up static code analysis by adding some files to the solution. You can download both the directory build props and the editor config from the links that are going to be under this video. Now let's examine the directory build props file. This is an XML file that's going to allow us to configure some build properties that we want to share between all of the projects in our solution. For example, I want to target .NET 8, for all of the projects that I'm going to introduce. I want to enable implicit usings and nullable reference types, but I'm also going to configure some properties that allow me to enforce static code analysis rules. The most important one that I want to enable is treat warnings as errors, but we're also setting the analysis level, analysis mode, treating the code analysis warnings as errors, and enforcing code style in build. And then the next segment is adding a particular NuGet package to all of the projects that we are going to add in the solution. And this is Sonar Analyzer C#, which is a library that includes many useful static code analyzers that are going to help us write better code. I wanted to introduce this from the very start of our project because it would be a bit harder to add this later into the project, and we would need to do a lot of refactoring. If we get this out of the way from the start, we're going to be forced to write code that conforms to the static code analysis rules that we configure. The condition that I have in place here just allows me to exclude this package for a DC proj file, which is just a Docker Compose startup project that we're going to be adding a bit later. The second file that I added is an editor config file, which is going to allow me to configure some code style rules for all of the files inside of my solution. For example, we can set the indent size, the indent type, what is the tab width, and many other coding preferences. And one more thing I'm going to do inside of the editor config file is to configure or turn off some of the less useful static code analysis rules that are added by the many analyzers that we have inside of .NET and inside of the Sonar Analyzer C# library. So with this basic setup in place, let's go ahead and add some solution folders. I like to add all of my source code inside of an SRC folder, and I will usually create the same folder structure that I have in Visual Studio also on my file system. The folder structure that we have in Visual Studio is mostly logical, and it only applies inside of your solution. If you open up the folder where this solution exists, you will see that the SRC file isn't created. So for keeping things consistent, I'm also going to create this inside of the folder. I'm going to add two more folders inside. One is going to contain my API project, which is going to be the executable application that we will be running for the Evently system. The second folder that I'm going to add is a modules folder where the 4 modules that we are going to build inside of the course are going to live. I said that the first module that we are going to build is the events module, so let's go ahead and add it. And now it's time to add some projects. Let's start with our API project. I'm going to add an ASP.NET Core Web API, and I'm going to call it evently.api. We're going to be running everything on .NET 8. I'm going to enable Docker, and I'm going to enable OpenAPI support. So let's go ahead and create this project. Let's go ahead and clean up the scaffolded project that we get out of the box. I'm going to start by getting rid of some of these comments. We will not be needing them. I'm going to get rid of the HTTPS redirection middleware and the default endpoint that gets added. And this is all that we are left with inside of our program file. Now you will notice that we are getting some warnings here, or errors, and this is our static code analysis working in the background. Here it's saying that I should use an explicit type instead of var, and here as well. So if I fix this, I should be able to build the project. One more thing that we get is a Docker file that's going to be useful later when we configure Docker Compose to run our application together with any external services. We're not going to be doing anything inside of this project other than the initial cleanup. We're actually going to be implementing all of the important stuff inside of the events module. So let's go ahead and add a project inside of this folder. I'm going to click add and then new project, and I'm going to introduce a class library here. I don't need to add another executable application because we already have that. And here is a naming convention that I like to follow when it comes to my module projects. So I'm going to start off with the project name, which is Evently, and then I'm going to say modules. The next thing I'm going to add is the name of my module, and then what is the name of the project that I'm creating. In this case, I'm going to have just one project inside of this module to start out at least, and let's call it API. I'm going to click Next. We're going to set this up on .NET 8, and let's go ahead and add a project reference from the Evently API to the Evently Modules Event API project. So I will add this project reference. We can get rid of this default class because we won't be needing it. And now I want to examine the project file that gets scaffolded for us out of the box. You can see that we are targeting .NET 8, enabling implicit usings and nullable reference types. And what I can actually do is delete this entirely, because if you recall, we configured this inside of the directory buildprops file right at the start. So our project is still targeting .NET 8, even though I removed this explicitly from the project file. Moreover, if I take a look at the NuGet packages that I have installed inside of the Evently Modules Events API project, you will see that the Sonar Analyzer C# NuGet package is actually installed for this project, and is going to be installed for all of the projects in our solution because we configured that inside of the directory buildprops file. So what is my plan for this project? I'm going to start out by implementing the vertical slice architecture for our use cases. So let's go ahead and create the first feature folder, and I will call it events. Inside of this feature folder, I'm going to create my first domain entity, which is going to be called an event. This is an interesting point in time to discuss naming conventions when it comes to our domain, because I decided to call this class an event. Because we are building an event management system, and it's also called Evently, we can think of the event type as a first-class citizen of our domain. The problem is, if you're not familiar, that C# also has a keyword called an event. So it's important not to confuse these concepts, and naming things well is one of the things that we can use to reduce confusion. So in this case, I could have decided to call this an event listing. This is just an example name I came up with, or it could be an event record. It doesn't really matter. The point is we want to name this differently to avoid conflicts with any language keywords that are available in C#. However, in this case, I think it's completely valid to call this an event because this is the term that is used by business people, and we really want to describe the concepts in our domain using the same language that people in the business use. So I'm going to wrap up this little discussion about naming conventions, and let's add a few properties to our event entity. So the first thing I'm going to add is going to be an identifier. I'm going to use a GUID so that I can provide a value on the client side and pass it to the database. Then I'm going to add a few string properties that are going to describe this event. For example, an event could have a title, a description, and let's say it could have a location. Then another thing that's going to be important for an event would be a date and a time when this event starts. So let's say starts at UTC. We could decide to define an end date and time. So let's create an ends at UTC property. However, I'm going to make this nullable so that this is an optional property in the domain. One more thing that could be useful is to create some sort of status property for the event. So let's create an enum that I will call event status, and I'm going to define a few states. So the first one is going to be a draft event with the value of 0. Then we're going to have a published event that's ready to be seen by the users in our system. Then we're going to have a completed event, which is an event that was successfully completed and it's now in the past. And we can have a canceled event when an event is canceled for whatever reason. let's also add an event status property to our entity. So let me create an event status property, and I'll just give it the name of status. I'm going to move the enum into its own file, and let's go back to our event entity. At this point, you might be screaming at me for not respecting any domain-driven design principles. For example, I'm exposing public setters, I'm using primitive types to describe something that could be a value object. For example, we could have a date range representing the start and end time, and we could definitely have an address value object describing the location. And while this is definitely useful in designing a rich domain model, it's not something that I'm going to focus on inside of this course. Rather, we are going to focus on modularity and how to build clean and logically isolated modules inside of a modular monolith. The next thing I'm going to do is to close up some of these folders because we don't need them, and I want to go ahead and install a NuGet package inside of my module project. So I'm going to look for MPG SQL, and I'm going to install MPG SQL Entity Framework Core PostgreSQL because this is the database that I will be using. Let's go ahead and install the latest version. I'm going to close this down, and let's go ahead and create another folder inside of my API project for this module. I'm going to call it database, and inside of this folder I'm going to create a respective database context because we're going to be using EF Core. So let's call this the events DB context. Again, the naming convention that I'm following here is using the name of our module to describe things. So in this case, I have a database context that's going to be available inside of the events module, which is why I'm calling it events DB context. Let's go ahead and implement the DB context base class, and I'm going to add a constructor accepting a DB context options object, and I'm going to specify the events DB context as a generic argument. And let's pass this to the base constructor on the DB context class. I want to comment briefly on primary constructors for classes because you're going to see me use this feature extensively inside of this project, and the reason for this is that it produces a bit more concise syntax. However, there is a slight problem with this feature when it comes to primary constructors on classes, so I'm going to override the onModelCreating method because I actually want to write some code inside of it. But to start out, I want to show you something. And if I try to access the options parameter inside of my primary constructor, you will find out that this is just a method argument or a parameter. And by extension, it's also mutable. So nothing is preventing me from taking a primary constructor argument and updating the value somewhere inside of this class. However, for me, this is a non-existent argument because I will never assign a value to the constructor arguments. And I also get some nice syntax highlighting because I'm using ReSharper, so it's easy to figure out when I'm working with dependencies that I'm injecting through the primary constructor. Now, back to our database context, what do I actually want to do here? Well, first of all, I want to start enforcing logical isolation of this module's data in the database by creating a schema for this entire database context. We can achieve this using the hasDefault schema method, and we can pass in a schema name. Now, instead of hard coding this, because I'm going to be using it in a few places, let me create a static class called schemas, and I'm just going to create a single constant field inside called events schema, and I'm going to give it the respective name. So now inside of our database context, I'm going to say that this database context has a default schema, which is called events. And let's also move these schemas into its own file. One more thing I want to introduce in my database context is a database set, which I'm going to make internal by default. And what I'm going to reference here is my event entity. Let's call this the events DB set, and we're going to give it a getter and a setter. At this point, we could go ahead and configure some of the properties on the entity by calling the model builder entity and then specifying our event type. However, most of this is going to be unnecessary because EF